All right, thank you everybody for joining our RVNUG meetup today. We appreciate all of you guys joining here. We also are starting a new program. Louis, you want to mention our new program that we're putting together?
Yeah, so starting in May, we're going to start a coffee and code program here in the Roanoke area. So if you're here locally, if you're nearby, we'd love to have you. If you want updates on that, you'll be able to see that on our social media. We'll be keeping that up to date. And also, we just started a Discord channel. So if you want to join that, I think it's in the chat right now. Ron just dropped it for us. He's administering it, and yeah, if you want to go ahead and join our community, that'd be great. And hopefully in the spring we'll see you there for some coffee.
Also, our face-to-face in-person meeting will be for this quarter next month in March. So the first Thursday of March, that's going to be March the 7th. We are going to have an in-person one at Medico. Thank you, Medico, for hosting us. And we are also going to send out information on that on our meetup, so stay tuned. But our online presentations are absolutely fantastic, and we always bring you fantastic speakers. And this month is absolutely no exception to that. We've got Kito Mann presenting on future-proof your web apps and web components in Lit. Kito Mann is the principal consultant at Virtua Incorporated, specializing in enterprise application architecture, training, development, and mentoring with microservices, cloud, web components, Angular, and Jakarta Java enterprise technologies. He is also the co-host of Stack D podcast and the author of JavaServer Faces in Action. Mann has participated in several Java community process expert groups, including CDI, JSF, and Portlets, and is the internationally recognized speaker. He is also a Java champion and Google developer expert in web technologies. He holds a BA in computer science from Johns Hopkins University. Really appreciate you guys joining us today. Take it away.
All right, thank you, Tolga. Thank you for reading my entire bio. I don't have to say anything about myself. That's kind of cool. All right, well, Tolga, you were the one that invited me initially, right? If I remember correctly.
Yeah, I think we met, and I think Alex was there too. So I think we were both talking to you. Yeah.
So I'm very glad to be here. So what I'm going to talk about today is LitElement and web components. And I will skip the thing about myself because Tolga said it all. The only other thing I'll mention is that I am working on this side project called Speaker Tracks, which is for frequent speakers. It's not out yet, but you can sign up for beta, and it is built actually using Lit and web components on the front end. So you can check that out if you like speaking in conferences. I wanted to get a handle from the rest of you in the meeting, like how many of you actually do front end development, and how many of you well, first of all, how many people do front end development? You can do the little raise your hand thing. See if that works. Okay, so I saw. Okay, so it's a decent number for you. Okay, how many of you have used React? Okay, so a couple of you. 3. All right. What about Angular? Okay. All right. Does anyone use a homegrown framework, Ball of Mud? Anyone use that? So I wonder if anyone does anymore these days. All right, cool. Okay, has anyone actually worked with web components before? Okay, so a couple people, awesome. All right, cool. All right, so that gives me an idea. All right, so I want to point out one aspect of my background, and that is actually, I'll go back here. So notice I was involved with a whole bunch of expert groups in the Java community, and the way Java, the way these things used to work, things would change, but initially there were enterprise Java standards, and there was like a standard body that created it, and then different vendors implemented it. And there was a pretty formal process, but it was what we considered standards. And now a lot of that has moved. There's actually an open source Jakarta EE project that does sort of the same thing. There's also this micro profile standard in the Java world as well. So I've always liked standards, and I like the idea of standards because it kind of keeps people from reinventing the wheel over and over again. I have done a lot of front-end and back-end development. I come from a Java background, and I found I was often on teams doing more of the front-end side of things with web applications. So when I started actually writing full-fledged JavaScript-based applications, I was trying to get a handle on what I actually liked and what I didn't. So I did, I did some Angular projects. I did some older frameworks like Backbone and Marionette and things like that. Marionette, I think. What I saw though pretty quickly was something that really glared my eyes, and it was something called web components. And basically what I liked about it is that it actually was a component standard, a standard for building UI components or any kind of component inside of the browser. And I've always really been into UI components. So in the Java world, I worked a lot on JavaServer Faces, which is a lot like ASP.NET. It was sort of like, back-end components that have like a front-end rendering part, but they also had a back-end part, but there's still component architecture. And before I got into that, I actually, way back in the day, I used to work with Delphi. Anyone work with Delphi before? It's got to be at least one person. Yes, I knew there had to be one person. All right. So I did a
C++ builder, but I use Delphi components.
That's good. All right, one other person there. Cool. So I was really into UI components and component models and things like that. So I've always been into that.
VCL.
Yes. And that was some good code. I still, whenever I think about looking at that, because that was, one of the great things about Delphi is that it actually let you see the source code, which was a big deal back then. And it was actually good code. Like you could read the code and see what the hell was going on, which was great. Yeah, those were the days. Anyway, so I like standards and I like UI components. And so I was always into that even before all these web frameworks were out. I was working with UI components in the Java world, right? So when I realized that there was actually a specification or specifications that allowed you to have UI components actually running in the browser, I was like, I'm sold. Let's see what the deal is. And you'll see this kind of point I have here is what's in the browser stays in the browser. And this is what I like about standards is that you can kind of count on them. Like, if one day, like the maintainer of your favorite framework decides not to do it anymore, sometimes that affects the ecosystem. Now, sometimes ecosystems are so large that would never happen, but sometimes they're not so big. And there's a few people that if they're not there anymore, the product dies. Or the company may change their mind, which is a good example of Angular 1.x, right? They decided to do something different, everyone got mad, story continues. So with web components, you basically have some specifications that allow you to use UI components that are native to the browser, which means they're faster. They don't require like loading a whole runtime and things like that. And it basically consists of a few core specifications, which are all part of HTML now. So the first one is custom elements. And custom elements is basically the ability to define an actual HTML element like an input control or a form or a div or whatever that actually the browser will treat just like any other element. And this is like the foundation, right? Is that you can create your own element. And when we're doing this, we're not just talking about, an element in the world of JSX or an element inside of an Angular component class. We're talking about an actual element that the browser understands. So we're talking about much lower level in terms of what's actually interpreting the code. So that's sort of the foundation is custom elements. But of course, you can create an element, but you also need to, probably have some additional markup you have to work with, like other elements, right? And of course, you can programmatically build a component tree. You can build a DOM tree programmatically, but that's kind of tedious. So if you want to be able to use some markup in your component, it's helpful to have something else, and that's called HTML templates or the template element tag. And that basically allows you to define a little, not a little, but a fragment of markup that you can then reuse in different places. And what's nice about that is that you can basically build out your template and then copy it and move it around and do things with it. I mean, you'll find that frameworks or different libraries will do other things like do interpolation and things like that on top of it. But at a bare minimum, the ability to have a fragment of HTML that you can reuse is what template element provides. Another thing that's key though is like if you have the element, you have the custom element you've made, you have the ability to define additional markup within it. You also want some encapsulation because if someone puts all the CSS at the top of the page, it could bleed into your component. You may not want that to happen. And that's where the other big feature called Shadow DOM comes in. And Shadow DOM basically is the idea of having a DOM tree inside of your component that's encapsulated. So you can actually turn it off so that the encapsulation doesn't do anything, or you can have it encapsulated so that styles on the entire page don't affect your component unless you want them to.
Kito,
yeah.
1 second. Are you sharing something? And if you are, am I the only one not seeing it?
No, you are right. Minor problem there.
I mean, you were actually explaining it really well. So graphical representation, but
yeah, this might help. Yeah, but you didn't miss much. Like all you missed was this.
No. We're good.
Here, this lovely picture here. There we go. What's in the browser? Say this in the browser. This is what I was referring to. But yeah, so Thank you for pointing that out, though. I appreciate it. All right, so we talked about custom elements, HTML templates, and shadow DOM. So those are like the 3 pillars of web components. And basically, you can write web components using all these things, and you're good to go. But of course, like many things, it's like they built these 3. These are all individual specifications. Once they're all done, they're all implemented at different times. Once they're all done, we had what we needed. But there are, of course, some rough edges. So, of course, there's related specifications that you can all consider sort of under the web components umbrella. And a lot of them are related to shadow DOM. So shadow DOM has been a little bit controversial at first because it breaks some things. Maybe you want your CSS styles to be available inside or to affect the component. Or let's say your component wants to expose some styles, things like that. So there's some specifications that help with this. And I'm trying to think, yeah, there's one which I didn't list, which is very important, which is called CSS properties. And I don't think I have that elsewhere. So CSS properties basically let you have variables for your CSS, sort of like what you get with SAS or SCSS, but built into the browser. So that's one thing. Another thing is declarative shadow DOM. This is a newer feature, which allows you to declare your entire shadow DOM as basically as an HTML template. Before, what you had to do was programmatically add stuff to your shadow DOM. So this just gives you a little bit more syntactic sugar. There's also CSS shadow parts. And that lets you basically expose part of your DOM tree, your internal DOM tree, via a pseudo element in CSS. Whoops, sorry, not meaning to do that. So that you can basically expose part of it for styling by the rest of the page. Another feature is constructible style sheets. And this is a really cool feature. This basically lets you programmatically work with style sheets and lets you programmatically add a style sheet to an actual DOM tree inside your component. So what that means is that you can programmatically create, well, not programmatically, but you can create theming capabilities that are a little bit harder to create with shadow DOM beforehand. But these are now here, which is awesome. So that's another feature. There's also a new one which is out, which I think just came out last year, called form-associated custom elements. So one of the issues with custom elements previously was that if you wanted your custom element to interact with a form and browser-based validation and all that kind of fun stuff and ARIA attributes the same way an input element does or any other input control, it was kind of a pain and didn't work that great. So they finally fixed that with form-associated custom elements, which is nice. And basically, it just gives you another this special class that you can access that gives you access to all the attributes and things like that, which is nice. Another related feature is something called HTML modules. So we all have we all know about the JavaScript modules, ES modules, right? And how those are now built into the browser. And one day I hope that all the other module systems in JavaScript will go away. But until it happens, we have the ES modules and the other sort of other modules like CommonJS, etc. But in the early days of web components, there was another module system that they were trying to create called HTML imports. And what they'd let you do was you could import a whole HTML document and treat it as a dependency. So part of your dependency tree also included HTML documents. But what's cool about that is that you could put an entire web component in an HTML file and then import it into your page. And that web component could contain markup as an HTML template and JavaScript code. And that was really nice. But the problem was that it didn't match with, it was a separate component model, a separate model, excuse me, from the ES modules. And Firefox and others were like, yeah, that's kind of going to be wonky. So they nixed it. And HTML modules are basically the answer to that. They allow you to still import an entire HTML document, but it's treated like a JavaScript module. And that one isn't quite baked yet. There's a specification out there, but they're talking about doing it again. So it might happen in the next year or so, which would be nice. Because one of the things about web components is that by default out of the box, you don't get the authoring experience of having an actual HTML file and the JavaScript code on the same page, although you can approximate it pretty well, which is what I'll show. So that's a story. That's what web components are. It's basically a bunch of specifications that are actually available. And they're available in pretty much every browser. And we don't talk about IE. But if you must, there actually are polyfills that work for IE. But I am happy to say, I have now, in the last couple of years, I haven't had any clients that had worked with IE. I think it's pretty much gone. Anyone else still use it? Anyone else have clients that use it or use it at work somewhere? So
Yeah.
Richard, are you raising your hand? Okay, maybe Richard's on mute there.
Sorry, I'm not.
Okay, all right, good.
Edge doesn't count, right? You mean pure IE, the original.
IE11, yes, not Edge. Edge is good since they, are just using Chrome.
Since they're using Chromium, does that mean they automatically stored everything like
Yep.
Chrome would?
Yeah, it's the same rendering engine, and they also contribute to it as well. So, but actually, it's one of those places where it actually is good that they did that, because they actually contribute to stuff. They fix bugs. It's actually a very good thing. And they can concentrate on their fancy AI features as opposed to the rendering stuff. So, but yeah, so all the Evergreen browsers support all of this stuff except for the HTML modules, which is awesome. And then the other question is, so what about my framework? What about my Vue or my React or my Angular? And fortunately, there is this wonderful site called Custom Elements Everywhere, which is developed by this guy that used to be an evangelist for Google. And it has a suite of tests that it runs against web components on every single framework, or every major framework, I should say. So first you have React, and React, it's okay. And it has some areas where it needs help. However, React, the new version, the experimental whatever, has full support. So it's coming in React, it's just not done yet. But it's very nice to see. But then if you look at every other framework, Vue, Angular, Sweat, AngularJS even, Preact, Skate with Preact, Polymer, which is older, HyperApp, Lit, which is different. The Lit is actually what we're talking about. Bride.js, Mithril, Omni, Stencil, blah, blah, blah. Okay. So a lot of other frameworks support it. So pretty much, if you're using a third-party framework, you can use web components with it, unless you're using React. And there's actually...
Tomorrow, there will be lots of clouds.
Alexa, stop. I need to turn off that feature. So, and even with React, the newer version, like probably sometime in the next year or so, they'll support it. And then also Lit specifically has libraries to help with React development. So just kind of smooth out some of those edges. But other than that, framework support is pretty good.
I think Alexa was telling you that React has a cloudy future, is what I got out of that.
Hey, you said that, not me. All right, so that's the story there. The other question, of course, is what about adoption? Does anybody actually use it? And fortunately, you can do these great searches on Google. And this is just Chrome stats, so it doesn't include other browsers. But you can see with Chrome, we're looking at about 20% of the pages accessed with Chrome, since Chrome does pay attention to everything, I guess, actually use web components. This just means that there's a web component on the page. It could have been something that was included from somewhere, who knows. But it just means it's on the page somewhere. But to me, this is a good sign. This means that adoption is going up quite a bit. So, and you can see how it's risen, just since in the last year. Last year's been kind of flat, but prior to that, I guess people were really busy during the pandemic working on it. So looks good. So, all right. So all is well and good, Kito. Let us see some code. So let's look at a very simple example. And what we're going to do is, oops, wrong one. We want this one. Okay. So can you guys see that okay?
Yep.
All right, good. Okay, so this is a custom web component. It extends HTML element. That's the base class for all of the custom elements. And basically, there are what you can define as observed attributes. And these are attributes that you want your component to pay attention to. And whenever any attributes on your component are changed that are in this array, it will then call this attribute changed callback. Okay, and then in here you can do whatever you want, and then whenever you want you can render, and that just means you basically change the inner HTML of your component, or you can add stuff to the DOM if you want, whatever you need to do. And you notice there's these callbacks here. So this is our constructor, but there's callbacks whenever you're connected to the page, whenever you're disconnected, whether you're dotted, if it was moved to a new page, a new document, and then of course when the attribute is changed. And these are kind of the low-level callbacks that you get from web components. And then here, you'll notice what we do initially is we do this interesting thing here. We attach a shadow root. We give it a mode, which can be open or closed. And we then create a div element, and then we render, which is going to append the HTML. So we could have done this more programmatically if you wanted to. You don't have to change the inner HTML. But basically, after we do all this, we append the child to our component. Okay, so the shadow DOM is basically our internal component tree that we're building, and you can build it however you want. And this example doesn't use an HTML template, but I could have used an HTML template and put that in here as well. So this is a very simple example. And so what this is going to do is basically just spit out some properties, right? It's going to tell you what the value of the foo attribute is and what the value of this dot bar is. And this dot bar is going to be a property on this particular component. Okay, so very simple. This is just pure JavaScript, nothing too fancy. And if you wanted to look at it, it looks like this. So, and let's go back here. We want a simple web component. Okay, so it says foo, bar, bar, foo. Very exciting, right? And what we can do, you'll see the element right here. You see it's actually just a web component, it's just an element in the browser. There's no fancy JavaScript, and it's actually just in the DOM tree. And I don't need any fancy dev tools just to be able to look at it. And then if I want to look inside of it, because the shadow root is open, I can look inside and say, oh, there's a div, and there's foo and bar. Okay, and there's some interesting things I can do. So I could say const my equals document element name. Need to be able to spell to be able to do this, apparently. I've been doing too much Java lately. All right, there's my L, right? And you want to say const my L equals my L. Okay, there's my element. And what if I did like, L dot set attribute who. Okay. So you see foo changed here, right? And it also changed here, right? And if I do the same thing for bar, okay. And what if I did this? Okay, that didn't seem to do anything. So I changed bar, but I didn't actually change it. But if I change bar here as an attribute, I do. Okay. Oh, you see, I can actually programmatically work with the component in the actual, because it's actually part of the component tree. I don't need developer tools. I don't need anything fancy. I can just work with it directly. That really is the power of web components. It's actually built into the platform. So all the stuff I'm doing here, of course, I can do programmatically. And of course, with some libraries and a little bit of work, I can do things that are even more powerful. So that's basically the idea. All right, do I have any questions so far? Okay. All right, so that's sort of the core of web components. And it turns out there's different ways to write web components. You can use pure JavaScript, you can use pure TypeScript, or you can use a library to make life a little bit easier for you. And like most things in the world, the libraries do help. You don't have to use them, but they make your life a little bit easier. So there's a few different libraries. I'll talk a little bit more about them towards the end, but my preference at this point is something called Lit. And Lit is the child of something called Polymer. Has anyone heard of Polymer? This was around a few years ago. Okay. So Polymer was basically a big project of the Google team, of Google, I should say, where what they wanted to do was sort of explore this idea of this brave new world of these web components, right? So we had, at that point, we had custom elements and HTML templates and shadow DOM, and we also had HTML imports, which only Chrome supported at the time. So what they did was they basically built out a whole framework that used web components. And it was actually really cool. It was a really nice framework. But it was sort of complicated. And one of the big problems I think they had was they had two-way binding. So that caused some issues, because we all know, especially if you look at any React app, it's always like props down, right? This had two-way binding, which was a pain to debug, and it has some other features. So eventually, they came out with something called Lit, or it was called, actually they had LitElement, which was a lightweight library just for helping you write web components. It didn't do any other frameworky stuff. And eventually they had LitElement and LitHtml, and they merged them into something called Lit, essentially. So that's what we have now. And the big difference between Polymer, which is more of like a framework, it was more of like a web component-based framework, whereas Lit is basically a small library to help you write web components. So they're very different. And what Lit gives you, and I think my slides went in the wrong order here. Let's see. Okay. So what we're supposed to see is Lit. Yes, Lit features. Okay. So this is a Lit feature, which I just skipped over. Okay. So the first thing you get are TypeScript and Babel decorators, and actually Lit 3, which just came out late last year, supports the new JavaScript decorators. So you can go with the standard decorators as well. But decorators, as most of you probably know, they just let you provide an annotation that basically does something fancy at runtime. Or compile time, depending on what you're doing. So that takes away some of the boilerplate that's involved. So there's that. There's also templating. And templating in Lit is done with tag template literals in JavaScript or TypeScript. So it's actually, as opposed to having some special language like JSX, it's all pure JavaScript. And the templating stuff, I believe it still uses HTML template internally, but you don't actually see that directly. Directives let you extend the templating capabilities, which is handy if you need to do anything fancy. And then there are reactive properties. And this is probably the biggest thing that libraries give you with components. So I showed you how you could basically set an attribute very easily, right? But often we have properties, and there's always this idea of what we call, property attribute synchronization or transparency or things like that. So you may, in some cases, you want your properties to be attributes. In some cases, you don't. And also, sometimes you want the attribute to be visible in the DOM, things like that. So having the properties and attributes being synchronized when you want is an important feature. Also, what Lit will do is update automatically when properties change. And that's another key thing. So you don't have to manually do an update. And the decorators that it uses a property decorator for public properties, and then state for private ones, which you don't want to expose externally. But they're basically the same thing. It's just that the state ones are just internal. So that's a really key feature of Lit, and this is going to be true for any library that helps you write web components. Now, what it does is it has this sort of rendering cycle. So you saw in pure web components, you just render, right? And I had a render method, but really I was just updating the inner HTML. That's all I was doing, right? So it doesn't really know about rendering per se. It just has those basic callbacks. So with Lit, you get some additional hooks. And it basically, you still have that attribute changed callback, right? But inside of it is actually doing some work for you. And then there's callbacks that you can hook into, like if you want to know if your property has changed, you can get a call. You can actually change this behavior. So you can decide, by default, it can tell if your property has changed by just doing a equal, but you can change what that means. But then also you can request an update, and then you can perform it. And there are some other callbacks you can look at, you can implement as well. There's update render, and then there's post updated ones as well. So it has a more complicated rendering lifecycle, which is built on top of the web components lifecycle, and then provides additional hooks in the lifecycle as well. So basically, it allows you to automatically update your components based on properties that change. That's basically the idea. So another feature it has is what are called reactive controllers. And reactive controllers are basically just, you can think of them as parts of a component that you want to reuse across different components. So it just has some functionality you want to use across different components, but it's more than, but you want it to actually hook into the component lifecycle a little bit. So that's basically the idea there. And I'll show you an example of that. There's also a context, which is basically a copy of the React context, if you ask me. Now, these are optional features. You don't have to use context. You don't have to use reactive controllers. You can just use the basic Lit stuff if you want to. So context makes sense if you're building an application with Lit, as opposed to just using Lit components in a React app or an Angular app or something else. So this is really more for that case. And basically, the way the context works is it's pretty much like React. If you have some state or some data that you want to expose to child components or parts of the component tree, you can do that really easy with context. It also has the idea of async tasks, which are basically just eliminates some of the boilerplate that happens when you have to call, do a fetch or some other operation that's asynchronous. And it also supports JavaScript mixins, so you can mix in functionality from another component if you want to, which is handy. And then they have what are called lit labs. So basically, what I like about the philosophy of this project is they have the core lit stuff, right? It's small, it's fast, and then they have different libraries that you can use if you want to with it. So an example of that would be the context, the mixins, I think the reactive, actually, I can't remember if the reactive controllers are separate or not, but the async tasks, those are optional libraries. And a couple of those libraries were actually lit labs projects beforehand. So each lab project is its own entity, right? And there's a few different ones. They have server-side rendering they're working on. They have a testing library, animation stuff. They have a router that you can use. They have integration. This is new with Preact signals. So if you think React signals or Preact signals are cool, you can use those with lit as well. So all these are like other sort of projects that you can use if you want to. And they're pretty like mature, but they're not like officially graduated from lit labs yet. So I like the fact that there's that ecosystem available as well. Okay. So who uses it? So these are adopters actually from the lit site, so these are mostly projects that use lit internally. You notice a few things about them. So these are pretty much component suites, right? So with the exception of Google, which of course uses it everywhere because Google is Google. So I suspect all of their front end projects use either whatever they've turned GWT into in the backend for all of their Gmail suite. And then a lot of Angular and some lit. And actually, I don't know what it is now, but the YouTube desktop site used to be written in Polymer. I don't know if they rewrote it yet, but so they use it for everything. But these other ones, like One Platform Components, Line Web Components, and Hello Framework, etc. These are like either components, suites, or their frameworks. So Spectrum Web Components from Adobe. So this is like a really powerful set of components. So the idea is that when you build stuff for the web components, there's two main use cases, right? One is you build components you can use with any framework you want, right? So web components are very often used for design systems. And I've heard of adoption stories from Microsoft and other companies where they're building them as reusable components that people can use with different frameworks. Or you can just build applications using them and not use a framework like React or Angular. And that takes a little bit more work, obviously, because those frameworks give you everything out of the box. Well, React doesn't really, but Angular does, gives you everything out of the box to use. So those are kind of the two main use cases. Okay, so let's look at a very simple example of lit. And we'll look at two different ones. The first one we'll look at is the JavaScript version of lit. So this is a very simple component. It has the static properties. So this is something that lit likes to have. And this lets you have properties which can also be attributes. This gives you that sort of property attribute transparency sort of thing. And then in our constructor, we initialize our properties, and then we have a render method. And since we're extending lit element here instead of HTML element, so render is a method in the superclass, so we're overriding it. And then we just return HTML and this function. So this is a template tag literal in JavaScript, and we can put all of our HTML in here. Okay, so this is basically how you do templating. And at first I wasn't really sure I liked this too much, but I've grown to like it because not only can you do things, if your IDE supports it, you can put all the HTML in here you want, but also you can easily throw in expressions because it's JavaScript. And then also you can write methods. If you have a complicated rendering, you can write methods for different sections of rendering. But it's not some made-up language. It's actually all just JavaScript. And then what you have to do afterwards, I don't think I showed this before, but you have to do custom elements.define and basically say, okay, this is basically telling the browser, hey, this is my component. Okay. Was there a question there, or is that just a little bit of noise? Okay. Looks like it was noise. Okay. All right. So this is a very simple element, and you see all it's really going to do is display the values of these properties. Not terribly exciting. All right, so this is the JavaScript version, and look, it displays the properties. Very exciting. And I'm gonna use the Chrome shortcut here, and I'm going to do plot1 equals. So you see here, I just updated the property, right? and it changed the attribute here, right? And it also updated the UI. So automatically with lit actually handles that because I put that in my array of properties at the top. So then I could do this, and so I could also do I also do it that way, and that's that attribute property transparency. Okay, so now I've got a pretty decent component and a little bit less code, which is nice. The TypeScript version looks pretty similar, but it's a little bit shorter because we can use decorators. Okay, and of course, if you were using JavaScript with Babel decorators or using standard decorators, it would look the same pretty much. The only difference, actually, it would look pretty much the same regardless, because this decorator here allows us to not have to do that component, that define at the bottom that we had before. So this you don't have to do, okay? And then we can just use property for each of these. And we basically just tell it what kind of type it is, and then we can do everything here. So again, it's gotten even shorter. And the behavior is exactly the same as what I showed before. So basically, just think of lit as a way to do some extra, to get rid of some boilerplate and give you some extra features for writing web components. That's essentially what it is. So that's the story there. Any other questions so far? All right. Did I miss a question? I just realized I didn't look at the screen. I just didn't hear anything. Okay, good. Okay. So that sounds all great, but how do I get started? There's two ways to get started with a new lit project. One is something called OpenWC. And I don't know if anyone's heard of this before, but it's called Open Web Components. And it is a group that helps you with guidelines and also scaffolding for building web component projects. So it talks about the idea of building web components, about what the modern web is, how you can actually build applications that are buildless, although to me, I find that works very well for development. So this particular project, when you do TypeScript, there is a little bit of build involved, but you notice that the code here, like this is actually a JavaScript module. There's no special bundling, but obviously in a larger application, you're going to want to do some bundling, stuff like that. So they tend to prefer rollup, but it doesn't matter. You can use whatever bundler you want. So this is actually a good place for just general guidelines and rules. It has lit helpers, and then what it also has is a generator. So with the generator, you can start a new project and you can decide whether you want it to be one for generating just a single component or a whole application. So this is one way to start. The other way to start is of course to go to lit.dev. And lit has a really nice site now. And it even has a little playground. You can go and play around and with examples that are live in the browser, which is nice. So if you just want to play with it, go to lit.dev. But if you want to start, you can, wait, where's the documentation? Here we go, sorry. You can basically start with a few different projects that they have, like they have some starter projects here as well. So, and there we go. Yeah. Okay, so I don't know where the starter is, but there is a lit start. There we go, starter kits. Oh, okay. So you can create it from here too, either with the starter kits. You can do a lit or I mean a JavaScript or TypeScript project, and it gives you all those things you expect to have. Both of these, either one will give you like a development server that automatically reloads if there's changes, and linting and a test runner and all that kind of fun stuff. And this also gives you a static site built with LitElement that gives you like a documentation for your components and things like that. So it gives you a pretty good starting point. So either of those ways, either of those options are good for starting. Okay, so I'll do a little bit more demoing here. So what I want to do is showcase an amazing little app project here called the Simple GitHub Repository Lister component. Okay, so this component amazingly will talk to the GitHub API and list, return list of repositories that I got back. So this is a very simple case, right? What's a question? Okay, so I make sure. All right, so this basic example. In the index.html, we have this component, and we're including this one JavaScript file here. And our component has one attribute, which is the actual query to send to GitHub. Okay, and so this is hard-coded with exactly what we want to send. Okay, and the repo list, or the actual component, looks like this. So we send a lit element, and we also have this thing, which I didn't talk about, and these are the CSS. So if you want CSS, you can use this CSS tag template literal function, where you can throw in all the CSS you want, and this will be rendered specific to this component. So this will be for the shadow DOM of this component, which is nice. And then this is a property, and you see how there's a reflect equal to true. So this ensures that this property is, whenever it's changed, the attribute is updated accordingly, which, as you saw, is pretty much the default anyways. Then there's the query string. I have a getter and a setter for it. Whenever you set the query string, it'll perform a query. It'll request an update for the query property. So this is kind of forcing an update here. And I have my connected callback. And then I have a render method, which uses that HTML function. And this, so basically all it's doing for each card is it's just rendering the results. And all the actual query does just is a simple fetch to the GitHub to get the response back. So, and then after it does the fetch, it requests an update. So basically, we've got a lot of stuff going on, but all I have to do is, occasionally I have to do a request update if I'm changing a property. But other than that, I've basically got, a fully functional little component and not a lot of code. Okay, and it also has its own CSS, which is nice. If I were to look at the actual DOM tree, and get rid of this. Okay, so you see this is that shadow root, right? And here's each section. And Lit has thrown in a little comment there, right? But you see we're basically just having each div, right, in here. And there's that section element that we had as well. All right, and that's what I've got there. So that's my initial component, okay? And if we look up here, we'll also see, oh, these are my plugins. This is all stylish for my plugins. Okay, yeah. Okay, so that's my very simple example. Let's look at a more complicated example. Okay, so this is the same thing, but we actually have a little bit of, something that looks a little bit better here, right? We have a whole little card, gives me more information about each component or each project, right? And then I can click on it and it'll take me to the product, right? So a little bit more interesting here. And the way this looks, so this looks pretty much the same, right? But the GitHub repo list looks pretty much the same, right? But you'll notice there's also this render card method, right? So when you render, it renders the section and then also does render card. Render card is going to use this other component, Virtua repo card, okay? And it's actually passing the value down to it, which repository it is. So this is an example of composition, right? When you have one component using another one. And I have actually up here in my imports, I am actually importing the repo card, and the repo card looks like this. Okay, so again, it has its own styles. Okay, and then it does this more complicated rendering here. Okay, so and of course it only renders if there's something to render. Okay, so now we've got things that are a little more interesting. We've also moved out some styles into another file, and I didn't actually show this before. This is just the interface for the for GitHub, which is being used internally. But so that's a little bit more interesting, right? Now we have a card, and we have it. I have a couple components talking to each other. But of course, we can go a little bit further. So let's say, like right now, everything that's happening is all hard-coded, like the query string and everything. So it'd be nice if things were a little more interesting. So we could actually change the query by doing a little bit of filtering. So let's say we only cared about Polymer projects, okay? Which of course old. So now we've got like a filter component, and then we also have the GitHub list component as well. Okay. So that looks like this. So we've got this virtual repo filter. We're passing it the topics that we care about. Okay. So let's say we wanted to see about I don't know, REST or something. We could put that in there. That'll be like the repo out there. So now if you see that with REST, I could do a search for all the repos that have REST in them. Okay. So I have the filtering going on. And you see there's these two components, right, and they have their attribute. And what we have in the filter is pretty simple, right? It is a component. There's actually the ability inside of lit to say if I am going to render a property as a attribute, I can actually have a converter, convert it to and from a string, which is pretty handy because what this component does is if we look at this query here, up here, so there's topics, rest, lit, whatever, right? But this is not maintained internally as a string, right? It's just being rendered as a string, but I can edit it as an attribute, and then it'll basically turn it into an object using that converter, which is pretty cool. Of course, A is probably not going to give anything, but I think that, and it'll give me a whole bunch of stuff. This is what this does. And this repo filter is going to basically has those topics that you can set, right? It has, of course, whatever the selected topics are. It's using the connected callback. The rendering just says, hey, choose a topic, and then it gives me an input control and a checkbox, or a set of checkboxes, I should say. And then if you actually, and this is actually a good example of event handling, right? Whenever the input control changes, I'm going to call this on topic toggle method, okay? And it's going to get an actual event, and then it'll look at the event, it's an input event, and it'll see if it's checked, etc. And then it does something else here. It creates a new custom event, okay, saying the topic has changed. And this is what's kind of nice, is because this is actually just the browser. I can just create a custom event. I don't need any special event stuff. Like the browser supports events, I can create an event. So what this does is it creates a custom event and then dispatches it. And what'll happen is that now in the repo card, if I were to look for, sorry, not in the repo card, in the repo list, first thing it does is it adds an event lister for topics change listener. And all that does is it filters and then takes that custom event, right? Whoops, clicked on the wrong thing there. Okay, so then it'll take that event and then it'll use it it casts it as a topic changed event, gets the detail, and uses that to change the query string. So basically, I have my component, right? My filter component. It does some work whenever you click on something, and then whenever you change the value, it fires the custom event, and then the main GitHub list component picks up that event and then updates the query string and then does another query to GitHub. Okay. So this is a very simple example, but we've got a situation now where we have actually two components and they're actually talking to each other, right? And I could have other components on the page which are listening for the same event if I wanted to, right? So this to me is a good example of how all the different standards sort of intersect. So, all right, so that's one other example. Another one I want to show you is this one. So this is the slots example. So you can also have the ability in web components to specify a slot, which is a section where the calling page or calling component can insert other components or other elements, okay? So here, I'm basically saying I want to, in my component, I'm putting in a couple of different elements, not just one, okay? And I have my header here. And then inside of this, inside here, if you look at when I do my rendering, I do something a little bit different here. So I say render header, and the class is card, header card, and then I insert the slot, okay? So basically what's happening is I'm basically inserting everything that's inside here in a certain place in my own component tree. And you can also have name slots. So it could have a certain slot that was just the header or a certain slot that was a footer or something like that. But this lets you basically have the calling component pass in markup, essentially. So the rendering of this, I'll go back to this. So you see I have section class equals card, header card, right? So if I go to this one, okay, and then I'll go in here, you'll see I've now inserted that slot inside here, right? So now it's like instead of before they were on separate, the filter component was separate, now it's actually inside the shadow DOM, which you may or may not want, depending on what you're doing. But it just shows how you can very easily insert the content inside of the component. So that's slots. And another feature I mentioned were CSS custom properties. So you'll notice this is not the most attractive page ever, but we could change things around a bit, right? You can make things bigger, smaller, whatever. So this is styled differently. And the reason is because we're using CSS custom properties here. So now what I'm doing is I'm basically passing styles to my component. This is an example of how we can style a component. So I said initially the style for the component can be encapsulated if you want, right? So now we're saying, okay, well, this component supports these particular variables. And I can specify them accordingly. So now I can change the font size, etc. These are only going to affect this particular component. The way this works, if we go to, of course, that doesn't work. Okay, but the CSS here, we have the slotted, right, which is the header, etc. And you notice here we specify variables: var header font size, var header font family. Okay, and this is just CSS custom properties. This is built into the browser as well. And then let's see if we have anything in the card as well. No, we don't have any variables in the card, so we only have those other variables there. But this lets us pass in variables that the caller can define. Okay, so that's what CSS custom properties do. And the last thing I'll show, my whirlwind tour, is a reactive controller. So I said before that a reactive controller basically lets you specify a bit of functionality that actually integrates with the lifecycle of the component. So in all of these examples so far, we've been doing all of the fetching inside the component itself, but we could abstract that out. So this is the GitHub fetch controller, which is a reactive controller. And it's got results, error message, and notice it has these callbacks. So has connected, has disconnected. And basically all it's doing is when you connect, it's doing a query. And then it has a public method that the caller can then use to perform the query. So it just moved this out of the actual component into another class, which any other component could use. So our repo list will then, instead of the other calls, it will, let's see. So our GitHub controller, see where that is. So whenever we render, we're going to get the error message from that, right? And then when we want to render the card, we can get the results from there, etc. And we know that it's called automatically when it's connected to the component. So, that's sort of an example of a reactive controller, and it could do anything you want as long as you want to hook it into that lifecycle. The async task is another way to do a similar sort of thing. It's actually a little bit better suited for this because it specifically deals with async, and it just handles gives you a basic way to handle errors and things like that properly. So it's another option. But that's basically the story. So those are a few different examples. Obviously, there's more we could do, but hopefully this is a whirlwind tour that gives you an idea about what it's like building with Lit and how it works. And remember that pretty much every framework will support a web component. And even though Lit is a library that gives you additional functionality, these are all standard web components. So any framework that says it supports web components can use these without anything else. Of course, they'll need a Lit library, but it's really tiny, so it's really not a big deal. So, all right, so that is my whirlwind demo. And we went through all of these fun features. So if you want to learn more, of course, there are resources, and I'll send you guys a link. So I'll get to put on Meetup about where where you can get this mind map, this lovely mind map, everything. But there is, of course, an awesome Lit list you can look at. So this is an old picture. I've not been here recently, but presumably it's got lots of resources there. Yep, there's a lot of stuff here. So if you want to hear all about if you want to find everything related to Lit, this is one place to look. Another thing I want to mention is I'll give a shout out to Stencil. So if I were to pick libraries for working with web components, Lit is clearly my favorite. But Stencil is another option, and Stencil takes a different approach. It takes more of a compiler approach. So basically, you build a component using the Stencil syntax, and they of course have a JSX variant as well. And then it compiles to a standard web component. So it's just a different way of doing things. But what makes it compelling to me is that it is actually used by Ionic. So has anyone heard of Ionic before? Anybody? Nobody, really? Okay, one person. All right. Okay, two people. All right. All right. So Ionic's been around a long time. They do components mostly for mobile web. But they use Stencil for all of their components now. So and they work with lots of different frameworks. So Stencil is another choice. And if for some reason you don't like Stencil or Lit and you still want to build a web component, you can always go to this is not the link I had. Webcomponents.dev. Okay. So this actually this is a great site. Webcomponents.dev gives you like a little workspace for any web component stack you can think of. It supports like over 60 different ways to make a web component. And this is cool because it gives you an analysis of all the different ones and how big the bundle size is and all sorts of fun stuff. Let's see where lit is on here. Yeah, lit 2. Oh, it's not. I don't see the timing on this one. Oh well. All right. So they've got yeah, they tell you the size and everything. You see lit is really small. It's like this is an older version, but it's only like 5K. So but if you ever just want to go and play with any of this stuff, you can go to not dev rights, sorry. You can go to webcomponents.dev and just pick up a template on any building a component with any framework. And it's not an IDE for web components. You can just start up. You can say, I want to play with the built-in wrapper in Vue, whatever. It'll drop a little VS Code, and then you can play with it. So if you just want to see what it's like to build a web component using Lit or any other framework, you can do it this way. So definitely something to keep your eyes on. And again, like actually now it's 64 different ways to build a web component. So lots of different options. All right, and also, if again you're wondering about, if your particular framework supports web components, take a look at this custom elements everywhere site that I pointed you to earlier. Good place to look. And there's also the state of web components in 2022 link. This is just an article, which is a good little synopsis of a little bit over a year ago about the status of things. So, all right, so that's pretty much it. You can find me on the internet at Kito99 on Twitter. It's at Kito99 at mastodon.social for Mastodon, which I prefer. And you can also find me at Virtua.tech. And if you want to link, this is the link to this particular example. Take a look here. So all right, anyone have any questions?
No questions? Wow, everybody understood it much better than I did, I think.
It is a whirlwind tour, so yeah, it's a lot to take in an hour and a half.
Yes. Yeah. Well, if you want to play with any of this stuff, check out the repo or go to. What I should do is figure out. I should try and get my repo up on like webcomponents.dev or one of these sites. There's actually lit.dev actually has the ability to play directly on the site too. So what I need, I think there's a way you can actually do this yourself. Like this is like it's all open source. So if I can figure out how to do this and put my demos in, I'll be happy. So
that would be awesome.
Yeah.
Yeah, I mean, I like the web component stuff there. I don't know why I've never seen that site. I mean, I should have seen that site. I think I might have seen it in passing, but I didn't realize you can just jump in there and it's just very interactive. That's very cool.
Yeah. And I should mention, just another general plug, all of the Salesforce is heavy in web components. They have these Lightning web components, which I presume if you write Salesforce apps, which I don't, but if you did, you would use those. So DevRiot, which is the company behind the web components.dev, they now have a Lightning web components dev site just for Salesforce Lightning web components. So it's that's another good indicator that it's here to stay. So. All right. Well, thank you so much. And I'll be around. If you guys post a meetup, I think I get an email about it. So if anyone wants to chat afterwards, let me know.
Thank you very much, Kito.
Thank you.
Thank you.